Most of you have seen some of my previous prototypes, so I'm not going to go through all of those again, but one thing that happened, so most of them that I've shown have been in plastic cases about, I haven't measured it, but I suppose on the order of an inch thick. And last year, I passed around a mock-up of what we thought we could do as far as making it slimmer. And so I'm going to pass this around again for anybody that wants to see the mock-up. So, however, as of less than a week ago, we no longer just have a mock-up, we now have a working slim calculator. And so this is, when you get a chance to look at it closely, I'll pass this around also in a minute, but based on feedback from last year's conference, there were a whole lot more people interested in a 42S-like calculator than a 41C-like calculator. So we redid the keyboard layout to match the 42S, except that we couldn't resist having one extra row of keys for the soft keys. And aside from that, the hardware is very similar. Let me check my notes here.
Where do we order and how much?
Well, I'll get to that. All right, so the objective of our project all along has been to build RPN calculators, and as much as I do like RPL, it was not the objective to do anything with RPL or anything like that. And we wanted a high quality display, and that's been one of the challenges. And we didn't want to go to rechargeable batteries, and that meant you pretty much can't do a color display without rechargeable batteries. But we wanted the calculator to always be ready for use, and if you have to recharge it, every few days or every week or something, then I don't know. I've always had problems with calculators that need rechargeable batteries. That the battery always fails at the most inopportune time, and I suppose disposables might sometimes do that as well, but seemingly not as often. So we really wanted to use disposable cells, and the way to do that was to make sure that the display was very low power. So it had to be a LCD display, but originally we thought it had to be either a commercially available character LCD or maybe a custom segmented LCD, and neither of those really gave us the capabilities we wanted. And then we found this display made by Sharp that is a 400 by 240 pixel display that's very low power. It's called Memory LCD. I described the technology last year, so I won't go into detail on that again. And the problem with that is that the display is horrifically expensive. It was about $45 each in low volume, which totally blows all our cost targets for this. And so the good news is that within the last year, the price on it has come down a little, and depending on which vendor we use, we know we can get them for about $35 in small quantity now, and possibly $25 from a different vendor. So we're still researching that, but that gets us a little bit closer to a reasonable cost target. So the hardware is still using a Energy Micro giant gecko chip, hence the name of the talk, which actually was changed from what I had requested. But so this is made by the company in Norway, and it's an ARM Cortex M3 with 1 megabyte of flash and 128 kbytes of RAM. And in addition to that, on the board we put 128 kbytes of FRAM, which is ferroelectric RAM. It's non-volatile RAM technology. We might not have that. We may drop that in the future because it is another fairly expensive part. And what we've got instead is, you'll see this better when I pass it around, but we've got a micro SD card slot, and we also have a micro USB for hooking up to a PC. And we've got an LED, which this one actually has a visible LED for debugging, but the intent is to put an infrared LED to be able to talk to the infrared printer. So the software right now is Thomas Auken's Free 42, which some of you may be familiar with running it on PCs or smartphones or the like. We are probably not going to ship this as a product with that firmware, although I may make the firmware available online since it is open source. The reason for that is Free42 was not designed with the idea of targeting devices with very limited RAM like this. And so eventually the RAM, if you use it long enough, the RAM gets fragmented and it can't operate any further. We viewed this primarily as being taking advantage of that software to do a prototype. And so also unlike the previous calculators like this one, we are not using any HP code in this calculator, so this one is entirely open source. And I just got the USB working within the past few months. Right now, there is, out of that 1 megabyte of flash, I've got the first 64K set aside for a bootloader. 44K is in use at the moment. More might be used later for more features, but it can. The bootloader will allow you to do a firmware upgrade from the micro SD or from USB from a PC, so you do not need a special programming cable or any fancy thing like that. So another drawback of using Free42, I've modified Free42 to take advantage of the display to show the full stack when you're in run mode, and the up to 8 lines of the program when you're in program mode, so that makes program editing a lot more convenient. So we ran into some problems with this, and Free42, by the way, when I pass this around, you should be aware that the resolution of this display is actually 3 times better on both the X and Y axes than what Free42 is using. Free42 was written to target the same resolution display as in an actual 42S, and we haven't changed that yet. So I'll pass a different one around that's not running Free42 that has a better, shows off better what the display resolution really is. But the biggest problem we have with the hardware now is the micro SD slot. So we're using 2032 lithium coin cells. We have 2 of them that are essentially in parallel. And so those provide nominally 3 volts when they're fresh, maybe even slightly more, but towards the end of life they're down around 2 volts. So we have an A to D converter in the microcontroller that we can use to measure the battery voltage and put a low battery message on the display. And we haven't determined yet, but with these batteries we would probably use about 2.1 or 2.15 volts as the threshold to set that indicator. And so to me, the first thing to do when I can see that indicator on is oh, the batteries are getting low, I better copy all my files to the SD card. Well, if you read the SD card spec, SD cards work on 3.3 volts. We have a boost regulator, so we actually produce 3.1 volts for it, even when the battery is low. But the SD card is allowed to draw up to 100 milliamps, actually even 150 milliamps if it's in a high-speed mode, but of course we don't use a high-speed mode. Now, different vendors' cards use different amounts of current, and some of them are less than that. We've seen as low as 60 mils, but the user could stick any SD card in here, and so we have no way of controlling that, so we have to assume that it's going to draw up to 100 mils. So when you're near the end of the battery life, what happens is the battery acts like an ideal voltage source with a series resistance, and that series resistance is what increases as you use up the capacity of the battery. So when you are down at 2.15 volts with very little load on it, and now all of a sudden, because your SD card's drawing 100 mils through a boost regulator, you're drawing 150 mils, you try to draw that much current from the battery, and your voltage sags down to under 1.5 volts. And the calculator cannot operate on that. It triggers brownout reset, and all the data that you were trying to save to the SD card is probably lost. So Rich attempted to solve this problem by putting 2 1 farad capacitors in the power supply. Now, when I was learning electronics, 1 farad was viewed as, this is a phenomenally large unit that's totally impractical. Nobody will ever make a 1 farad capacitor. Actually, you can get 1,000 farad capacitors now because the technology's advanced so much. Well, this introduces a different problem. With 2 1 farad capacitors in the power supply input, you put in the coin cell, and it has to charge those up, and the voltage ramp takes forever, and the calculator will not actually start up. For debugging purposes, we often power it either through the USB or through a paddle card that we stick into the coin cell socket, and use typically then AA batteries to start it. And actually those can supply enough current to charge those more quickly, and then it starts right up. So without some rethinking that how the electronics works as far as those capacitors, that's not a viable solution to the SD problem. Yes?
You can look at it this way, it's kind of like a jump start. It started.
Yeah.
And
Yeah.
then on your
Well, and it turns out, so there, in addition to those 1 farad capacitors, and because we had trouble with those, Rich clipped them out of the circuit, so they are not on this unit, but there was still a 47 microfarad capacitor. We don't know for sure that's the cause of the problem, but actually the calculator still will not necessarily start up from the coin cells. Rich says he's seen this on the prior prototypes. I have never seen it until he brought it to my attention, and of course that jinxed it, and now I see it on all of them. So we do have some power supply issues to sort out. I can't remember whether I conducted the straw poll for this at a previous conference or not. I kind of think I did, but I don't remember the results. So I'm kind of curious and like to see a raise of hands. How many people think it's important that the calculator be really slim and that they would actually prefer, well, let me tell you both alternatives. The first alternative is have it be very slim and have it run on coin cells like this. And the other alternative is make it more of a traditional wedge shape and have a pair of either AAA or AA cells down here at the display end, so there would be a distinct wedge to it. It would be thicker at the display end. So show of hands for how many people think that it ought to be really thin and run on coin cells. Okay, and show of hands for how many people think it would be perfectly okay to have AA's or AAA's. Okay, that's the overwhelming majority. This is the exact kind of market feedback we need because, well, frankly, we wouldn't be surprised if the people in this room aren't nearly our entire market for selling.
Eric, how about ask again between AAA and AA?
Oh
Okay,
yeah,
so
do
background,
that.
background on that. I've done the modeling in SolidWorks. Here, I'll show, and I'll pass around. These are 2 of the older units, and most people have probably seen them before. But I've got one of the older models that is made from laminated laser-cut acrylic layers. And one of the older models, this was my first experiment in using a 3D printer to print a case for a calculator. And so I did the modeling. Rich designed the layered case. I did the 3D printed in SolidWorks. And I am by no means even close to being an expert on industrial design. In fact, I think it's fair to say that thinking that you're an industrial designer because you have a copy of SolidWorks is exactly akin to thinking that you're a professional photographer because you have a copy of Photoshop. It doesn't work that way. So I learned a lot doing that, though, but I'm still far from being an industrial designer, and we may cough up some money to pay an industrial designer to do some of this work at some point. But what I've done is in SolidWorks, I've done a 3D model of a calculator with the AAA or AA cells, and on screen that seems to make very little difference whether it's AA or AAA. But seeing it on screen is not at all the same as holding it in your hand. So I really feel like I actually need to do a 3D print of each of those and stick the cells in them and weight them so that they would just be dummy mock-ups, but have them be approximately the right shape and size of the calculator with AAA's or AA's to determine whether it's really distinguishable. My gut feel looking at just the SolidWorks model on screen is that there's not enough difference that anybody's going to care. But that being said, if you had a choice between the two, how many here would prefer AAA cells?
Well, let me ask you a question. What kind of difference are you going to get in how long the calculator works between the two?
Well, probably twice as long.
Somewhere around 2 to 1 or 3 to 1. The AA's definitely will last significantly longer.
AA's are cheaper.
And they're cheaper. So I'm sorry. Let's try this again. AAA's. I'm not going to actually count, but
How
just
many longer life?
AA, twice as long.
How many AAA's?
it would be 2 in either case.
Two.
Okay, and how many would prefer the AA's and longer battery life?
Battery life.
Okay, and that's not as overwhelming as the wedge versus the coin cells, but it is. You guys are definitely predominantly in favor of the AA's, so I'll take that under advisement. I'm I'm not promising that that's what it is, since I'll actually try the mock-ups. So I'm going to go ahead and pass this around. This is, as I say, running 342.
Aren't an option?
I'm sorry?
C cells aren't an option?
No. If you want to do that, Rich might be willing to sell you the paddle card that we use for development. That'll let you plug in any batteries into it you want.
How about an adapter for a adapter?
Remember the 48, 46, 48? They had the slots for the
Yes.
It's a mock-up.
Well, I know you don't like the jump move, but if you want 2 slots, you're gonna go wedge shape, you can stuff piece in one, leave the other one blank, you got about 2,400.
We'll consider it, but we really like micro SD because that's, anywhere that you buy camera supplies has those.
Oh, I see. But I was saying,
Okay, there'll be time for some more questions. I've only got a few more things to cover.
How about
so-
an adapter for the lantern battery like
Yeah,
we did in the 40?
yeah, well, that's why I say Rich does have
Well, except it's only 3 volts.
the adapters that we use for debugging, and you could use a lantern. Well, you could use any 3-volt source with that. I've only got a few more
6
items, and then I will
volts.
take more questions. So what we really intend, like I say, we're not intending to ship the calculator with 342 firmware, although we probably will make it available online, but it'll be kind of an at-your-own-risk sort of thing. I have submitted the patches to 342 that support that 8-line display, actually is parameterizable in the source code, back to Thomas Aachen, and he's expressed some interest in actually making that available on the other 342 platforms, but that has not happened yet. The main, aside from a few minor electronic changes, the main things that we still need to do on this are going to be to get an injection molded case, or, and I've been talking with Jim Donnelly about this since he does a lot of really nice machining, we're considering a limited edition case machined out of aluminum and either anodized or titanium aluminum nitride coated. And this would be phenomenally expensive, but I'm curious as to, are there any people in the room that would like a really, really expensive aluminum calculator?
How expensive?
Yeah, I can see that.
So that's a difficult question to answer. I think the safest thing to say is that it's going to be over $1,000, probably well over $1,000. It can't be we can't do the kind we want entirely out of extruded aluminum, but using an extrusion as the start for where we machine it might be viable.
I'd go for it.
How about polished brass? Polished
Well,
brass.
it won't be solid. We're definitely not doing solid titanium, but the titanium aluminum nitride coating is very nice and it's very hard. Okay. And then the other hurdle is that we need to get, for sale in the United States, we need to get FCC Part 15 Class B certification, which
That's not
means
easy.
we have to take it to a test lab and pay for that. And the pricing on that apparently has come down in the last 10 or 15 years from what I was accustomed to before that, so that's not quite as big a hurdle as we expected.
Why don't you identify the calculator as experimental?
We can't sell them if they're experimental. We can send them to people, and we can have them marked on the on it that it's prototype, not for sale. But we can't actually sell it.
You sell
Get a partner in China.
with it for an instant book,
Mhm.
charge $500 for a book, and you gift the calculator.
Yeah. Okay, I'm going to talk a little bit about development. So I said it's an ARM Cortex M3. This is the microcontroller profile of ARM, so it doesn't have an MMU. And it only executes the thumb instruction set, which is the compacted instruction set for high code density. But you can use pretty much any tools that you would use for ARM microcontroller development on this. So there are commercial tool chains from people like IAR or from ARM themselves. We're using GCC since that's open source, and so the price is right. And I mentioned that with the USB bootloader or with the bootloader, you can either load new firmware from USB or from the micro SD card. If you want to do development, you may well want to program it and use a debugger, and so then you need a hardware interface to it. And so there are maybe some kind of open source alternatives for that. They're essentially they're not quite there yet. So what we actually use for programming this is there's this cute little board energy microcells called a starter kit, and this has a giant gecko chip on it, but when we use this for development, we don't use that chip at all. There is another chip that's hidden under this LCD display that serves as a debug interface, and so it talks USB to a PC, and then this header is, you can think of it as being like JTAG. Everybody probably is aware of JTAG being used to debug and program parts. These chips don't actually use JTAG, they use a proprietary ARM interconnect called SWD, but this board will act as the USB to SWD interface and allow you to do the debugging. And it sells for about $80, so it's not too bad. And you can see it comes with a USB cable and a CD and some stuff. And you'll need, for the new calculator, this is an old 10th inch centers header. The new calculator and the new ARM debug connector is a fine pitch header. And so when you get this board, it won't quite be sufficient. You also need an adapter cable that goes to the fine pitch. And you can get those from TI for, I think they were under $15. So altogether, under $100 to get the hardware that you need if you want to debug. But like I say, you only need that if you really want to hack on the firmware. Otherwise, you can just load it using the bootloader. They also have, and I've showed this before, and I'll have it up here for anybody that wants to see it later, but there's a more full-blown development kit that is a larger board that has a big LCD display and a prototype board and all sorts of other stuff. So if you want to do serious development for this chip, you might want to consider one of these, but it's not necessary. So all the stuff, I'll send a few more things around, but all the stuff will be available. Oh, the large, it's called a DVK board, and they sell for about $300. And so, and one more prototype around, actually two more. So this one was the earlier one that is running 41CX microcode. And so we're, based on the feedback, we're not intending to produce this, but it does show the display resolution better because the font is at full display resolution. So I'll pass that around. This one was last year's attempt to have the 342 code running, and it does work, but the keyboard layout is all wacky because we had to wedge it into the 41 keyboard layout because that was what our hardware had at the time. So pass that around when you're done with the other. Yeah, no door prizes out in this stuff. We still need it for development. And did I already pass around the? I must have already passed around the working slim prototype.
Yeah.
Yeah. Okay. Good. Just want to make sure I hadn't lost it.
I think
So-
it's in Jeff's hip pocket.
Okay. So I certainly will entertain any additional questions. Yes, Jeff. Gene.
From those kits that go on the museum, the 34S team is obviously in communication with you guys?
They are. We, about a year ago, proposed to them that, hey, we're going to have this, more capable hardware. Of course, it's more expensive also. But would you be interested at the time? We just asked whether they'd be interested in doing, a slightly enhanced version of 34S to run on this. And they actually didn't want to do that. They wanted to do a substantially more capable calculator developed almost entirely from scratch, and that they're calling 43S. And so this will obviously combine the better capabilities of their 34S firmware and the 42S and all sorts of amazing other new things that they think up. Yes? The 42S firmware that's currently in there does have basic clock functionality that you can set the time and read the time back. Actually, the one I'm passing around, I'm not sure if that's enabled or working correctly. The hardware will in fact have the crystal, and so the firmware almost certainly will provide a clock and maybe alarms, or those 34S guys are amazing. I'm sure that it'll have all sorts of nice features in it.
I don't know my scientific calculator can't have clocks.
Okay, any more? Okay, any further questions? Yes.
keyboard, physical switches.
So what we're using on this prototype, and we may change them again before production, the tall prototypes use an Alps tact switch, which had a square actuator that was fairly tall. And the new slim prototypes use a different Alps tact switch, which is fairly low profile, but nowhere near the lowest profile they make. And so the keyboard, as you see those, the keyboard is these tact switches with a laminated piece of photo paper as an overlay to give the key legends. To put a calculator into production, we intended to do injection molding of a more of a very traditional sort of calculator case and buttons. We looked at doing just the snap disk sort of keyboard ourselves, and there's a company here in Colorado, I think in Longmont or near there, called Snaptron, that actually makes metal snap disks intended for use in keyboards, and they make a wide variety of them, different diameters and heights and shapes and forces and whatnot. And it turns out that in the kind of quantity we're likely to be able to produce this thing in, those snap disks alone, which are not a complete keyboard, you still need other stuff, cost more than the Alps tact switches. So it's highly likely that in production we will use the Alps tact switches. And that has the advantage, that being manufactured in extremely high volume by Alps, it's not R&D on our part. If we build our own keyboard and buy snap domes from Snaptron and try to make it ourselves, maybe we could do a good job, maybe not. Whereas if we use the Alps switches, they're going to be very reliable.
But you'll still need some kind of physical plastic keycap.
Yeah, that's part of what I have to design in Solidworks and have injection molded. And I guess I should mention we have possibly the prices of getting tooling done for injection molding have come down dramatically over the last 15 or 20 years, but it's still somewhat expensive, especially for what let's face it. I mean, this is for Rich and I. This is a hobby project. We as much as we would like to get this into production and sell it, it's never going to make us any money. In fact, I fully expect we're going to lose our shirts on it. So it's a labor of love, and so as such, we have to be as cheap as possible. And if we can find a cheaper way to do just about any aspect of this, we have to take it. So if you want to get cheap tooling for injection molding, you go to China. Well, that works if you're going to have something made in the tens or hundreds of thousands or millions. That does not work if you're going to make 100 of something. They don't even want to talk to you, and who can blame them? It turns out we met someone here in Colorado who made a new product that he needed some plastic injection molding done, and he wasn't expecting high volumes, at least initially, and the people in China didn't want to talk to him, and he had some connections in Vietnam. And it turns out that the companies there really want our business, and they are willing to do it on a more speculative basis and don't demand that you promise them and high volumes and sign contracts for just immense number of units. So in addition to selling his product, he said that he actually wants to start essentially a service hooking up product developers in the U.S. with manufacturing in Vietnam. And so we're hoping that we may actually be able to get the injection molding done on the cheap that way. Any more questions?
Rough guess at the non-aluminum unit cost, rough?
Very rough. We were expecting somewhere in the $250 to $300 range. Since the cost of the display has come down a little bit, that makes it more plausible at the lower end of that range rather than the higher end. There are still a whole lot of variables, so it's really hard to say. We understand that it's less appealing to most people at a higher price, and so we would like to try to keep it as low as possible. But because we anticipate this will always be low volume, it's never going to be on the hang tag at Walmart. We'll be amazed if we ever sell more than 100 or 200 of these things.
Do you think Monty might be able to help with this, who did the 41CL, as far as the hardware goes?
If we needed help with digital design, I'm sure that he would, but I think we have that pretty well covered. money is definitely very sharp, and what he's done in the 41CL is just incredibly awesome. I obviously never got to the point of having anything that I could, deliver to anyone else, but I had spent a little bit of time trying to FPGA, and as such, my design was full 56-bit parallel, and the consequence of that is that it won't work as an upgrade for a normal calculator because it draws too much power and it needs a bigger FPGA. But what he's done is fabulous. No question about that. Yes, Tim.
I was just going to point out, so I've got these old surveying things from before I started at HP. So this is a fairly simple mold, fairly large one, relatively. But so this mold, you're running. We got it very, very cheaply done at 85K. So.
That production mold?
Production mold.
How long
So.
ago? With how many units?
So that's a steel mold. So this is a 35% fiberglass, heavy duty. So, but you're looking anywhere from 40 to 100K per mold, depending on the size.
When?
You can get much lower than that if you're doing like you get in Vietnam. There's people there that will do really cheap molds for like shoe soles. You can get down to a few thousand. But that's a very, very soft rubber material, not expected to last for more than 1,000 shots, that type of thing. That's the cost that's the killer. It's not the electronics and the software. They can handle that.
Tim's absolutely right, and probably we couldn't justify, since we don't expect to have that volume of units anyhow, we probably couldn't justify a steel mold even if we could get it for substantially less than that. We're probably looking at an aluminum mold, which, as Tim says, then is not good for anywhere near as many shots.
Instead of having Jim make the case for you, have him make the injection mold.
Yes.
Have y'all considered, maybe this is heresy, designing your keyboard so that keycaps from old non-functional HP calculators?
Yes, that's heresy.
No, we have not actually considered that. That's an interesting idea. Okay, if there are no further questions.
And I probably asked you this last year, so I apologize if I'm asking it again. And furthermore, I'm sure you thought of it yourself, and I want to know why you decided not to try any kind of crowdfunding.
We considered it. There are a couple of things. So the most famous crowdfunding site is Kickstarter, and as a result of some problems with certain projects that were funded through that, they changed their policy, and for a product that involves hardware, they require you to essentially have final hardware before you can launch the Kickstarter. And so we aren't to that stage. We could maybe do that in the future. The other problem with it, and I guess it costs us nothing to do the experiment, but since we do believe that it's very low volume, we don't think we could actually raise any significant amount of money through Kickstarter to actually facilitate this. It's something we'll have to consider further. Okay, thank you very much.